Now, all right. So we take a look at page. Turn to page 131. Page 131. Now, today we will continue on the practice questions on the titrations. Okay, so there are so many different types of titration. Besides using the X-based indicator to monitor the titration, you may think of using pH meter to monitor the pH, to change the pH of the solution, and also you may have 17.11 conductometric titration. So this is on page 131, and to start with, you may read that 2 pages first of all. Okay, I'll give you about 2 minutes to read this before we continue. 2 minutes. I'll read this. Okay, so for the conductometric titration, it's applicable to all types of X-based titration. Is it applicable to all different types of X-based titration? Take a look on that. Now, For this conductometric titration, the principle lies on measuring the difference in the electrical conductivity of a reaction mixture while I add the two chemicals together. Okay, can you find it? So the question comes. Now I try to give you this one example. I try to add barium hydroxide now to sulfuric acid. Okay, I put it against sulfuric acid, and during the whole process, why is that change in electrical conductivity? Can you spot for the equation? What makes the difference in the electrical conductivity? Can you see the word? Okay, we've got the precipitate of barium sulfate that may be formed. The more the barium sulfate is formed, the electrical conductivity that will be, right? So you may see there is a trend like this. Can you see it? So what happens when after Y, what happened to it? The electrical conductivity increase. Why? Why?
因為氦柱將 iron 咁嗰個sulfuric X 入面有氦柱將 iron 嘅。
Yeah, so 即係點啊？如果你話有即係 only hydrogen ion that were responsible for the difference in electrical conductivity. Now, so in order to answer that question, you should know what is Y in this case. What is Y in this case? We will call this the point where acid and alkaline would exactly react according to the equation right? The mole ratio listed in the equation. So we will call this equivalence point. That is exactly when the alkaline and the acid react. Okay, can you get my point? So at equivalence point, what we'll get is just the maximum amount of barium sulfate is formed. Okay, so which means that from X to Y, or the more acid is added, the more amount of the water insoluble barium sulfate will be formed, and which will make the total mobile ion concentration drops. So remember, this electrical conductivity is related to mobile ion concentration. Okay, the more mobile ions they are found there, the more concentrated the mobile ions are there, the higher the electrical conductivity. Remember, it's not a logic of more or less, it's a logic of more concentrated or less concentrated. That is different, huh? So you may see from X to Y, they will experience a drop of electrical conductivity because the mobile ions drops because of the formation of barium sulfate. Okay, is that clear? So what's next is on so you may see that one, right? So concentration of barium ions hydroxide ion drops. So we will call that mobile ion concentration drop, right? So the electrical conductivity will drop. What's next is falls almost zero at equivalence point Y, because barium ions and hydroxide ions have all just been removed completely. Has almost been reacted. All right. So after Y, what happened is that I add whenever I add the chemical to it, it is sulfuric acid. While that sulfuric acid will be no longer reacted with some other chemicals. So in other words, we are adding more mobile ions there. Where are the mobile ions? The hydrogen ions and sulfate ions. So the concentration of mobile ions, now I change a little bit, right? Which refer to mainly hydrogen ions and sulfate ions, increases. Okay, when excess dilute sulfuric acid is added to the reaction mixture. So electrical conductivity increases from Y to Z. Okay, can you get a point? So I use this as a way to, and also we can determine the equivalence point from this setup. Okay, any questions? Any questions? So finally, we have got 3 rays. Do you realize? You just introduced with you 3 ways of the determining the equivalence point for this reaction. 有冇留意到？ We just introduced 3 ways， 3個方法。我哋噏咗3個方法 is used to determine the concentration at the equivalence point. What are the 3 methods? What are the 3 methods? 1, I use the pH meter, right, to keep track of the change in pH of a solution. And from the pH titration curve that can be plotted, we locate the equivalence point. How can we make this? It's done by having you need to draw the 2 lines, this and this. Okay, and also this. So you locate that 3 lines and check the midpoint and of this 2 intersection point. Okay, so it is here. Can you get my point? Now we have you draw 3 lines, and we've got 1 point here, 1 that point they intersect each other, and use this distance you find the midpoint. And this is the equivalence point. Can you get a point? Now this is the first thing. Do you understand? This is method 1. Method 2. Method 2 is to use indicator, right? Acid-base indicator. So we would not use universal indicator. The reason behind is that universal indicator changes the color variously, right? At a slightly different pH. So it is quite difficult for human to judge where is the endpoint that. That because the color changes anytime. Even though you add 1 or 2 drops of solution, the color of solution already changes. So you may find it hard to locate the equivalence point. So is that we rely on the on using the indicator in which it changes color at different pH. The first one is beta orange. It mainly changes its color around pH 3 to 5. And phenolphthalein, you mainly use it to have change in color around 8 to 10. And going back, then depending on the nature of the different combination of acid and alkali titration, and you may know that they will experience a difference in pH, and I will use different indicator. Strong acid, strong alkali, you use either indicator. Weak acid, strong alkali, you use phenolphthalein. And strong acid with alkaline, we will use beta orange. But for weak acid with alkaline, you use either one. Okay, neither will be possible. So this is the second part. Now I'll give you 1 minute to uh, to to uh, to read this through again, and I would like to show you one exercise. I would like to show you one exercise, and please finish that. It's on page 146. This is our third method. 146. Question 24. Question 24. This one. Okay. Now, please do it now. I give you about 5 minutes to have a try on it, and I would like to have a discussion afterwards. All right. Finish. Now, these questions involve the monitoring of the difference in the electrical conductivity, right? So the question would be this: the barium sulfate can be made of exactly the same scenario as the one you see in the textbook. Check the physical quantities, right? I add X into the conical class, but instead the barium hydroxide on top. Very similar. Can you see that? the barium hydroxide solution here, while the conical flask, it is sulfuric acid. And you are going to keep track of the electrical conductivity by having the probe to monitor the electrical conductivity and collect the data log. Now the whole scenario will be this. Okay, so we will call that the conductivity meter, right? You may find it here, or you use this one, right? According to this, instead of using computer, you use conductivity meter, right? We've got the meter detail. Okay, you got it. So you may see that table, but the trend very similar to the one you see in the book. Questions in the graph, use the graph to estimate the relative electrical conductivity of sulfuric acid before any barium hydroxide solution was added. Estimate. Can you see the word estimate? How to estimate? Now go back to here. Where will you see the relative electrical conductivity of sulfuric acid? Somebody will say that at the very beginning. So what does it mean by beginning? Well, no alkaline is added, right? No alkaline is added. Where? So it may be somewhere here or near 600, right? Near 600. But the way to solve, you use one technique. I would like to introduce to you one technique. We've got a technical term. We've got one chemical term. We call that extrapolation. Extrapolation. Now, first of all, now you may see that if the line is drawn in line with this, right? Can you see that? I just draw a line which is in line with in the parallel with that original line, and I use this to project. Okay, you get my point. So you use you do it in practice. You simply use a ruler for help, right? And we will call that extrapolation. 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 外推法. So it is a way to project what will happen next, right? Is for ease of the data treatment. So we will call that the extrapolation. So that data will keep track of you, and you say that it is in line with trend, and go to around where? Where is it? 630, is it? 630 to 640. Give me that. 630 to 640. And this is where we talk about it as extrapolation, the techniques. Is that clear? So in this case, what you're going to do is to do the extrapolation. So on the graph, at 630 to 640, about around this. Is okay? Now, how about A2? Explain why sulfuric conduct electricity. Why it contains what?
Mobile iron, mobile hydrogen iron 同埋 sulfate iron.
Yeah, mobile ions. In particular, you talk about hydrogen ion and sulfate ion, mainly, right? Of course, in between them, you should have some other ions, just like hydrogen sulfate or even hydroxide, right? But it is very rare. It's very little. So mainly hydrogen ions, sulfate ions, and hydrogen sulfate ions will be present, responsible mainly for conducting electricity. Okay, A2. What was the volume of barium hydroxide solution added when the relative electrical conductivity of a mixture was the lowest? Electrical conductivity was the lowest. So what are they heading for? They want to locate equivalence point. Equivalence point, right? As EQUI VALENCE, equivalence points. This is the point where the two chemicals exactly react. So where is it? So again, you use this and locate 22.5. Is it? About 22.5. cm3, okay? 22.5. Why wouldn't we use how many decimal place do you have? Now each grade line just 1 cm3, right? So the uncertain digit is just the first decimal place, right? So you may find that 5.5, not 0.54. Do you understand? How about 2? Such as why electrical conductivity became almost 0. Why? At that point, what happened? Or H2SO4 is reacted with barium hydroxide, or sulfuric acid is reacted with barium hydroxide. So to give water insoluble barium sulfate, okay, almost no dissolved ionic substances are found. Almost no dissolved ionic substances are found in the solution. So the electrical conductivity drops to the minimum.
阿 Sir 阿 Sir， 我想問 BI 嗰個係咪應該22.5？
22.5
B 係咯，應該22.5。
Yes, I just said it. 22.5. 22.5.
唔係你寫嗰時寫咗25。
但係你寫咗25.5。
Oh, thank you. I read wrong. Thank you. 22.5. Okay. Now should you mark it? 22.5. Okay. Now see the questions on the calculations. What was the concentration of the sulfuric acid? So you stick back to that data, our 22.5 cm3 of barium hydroxide reacts with sulfuric acid of about 25.0 cm3. So you start from this. So it is about 1.20 mole per dm cube, 22.5 cm cube. Sulfur oxide molarity, I don't know. This is what we would like to find. But the volume is 25.0. So you start from this. According to the equations, equal moles of the two chemicals react. Okay. So according to the equation, number of moles of sulfuric acid equals number of moles of barium hydroxide. So you start from this. You calculate this, and you may get 1.20 mole per dm cube, and 22.5 times 10 to the power minus 3 dm cube. While number of moles of H2SO4, you will calculate it as 0.0270. Okay, so you go back to the concentration of H2SO4, which is equal to the number of moles of H2SO4 over volume of H2SO4. So you may get it as 0.02070 mole over dm cube. Remember, dm cube. So the volume of it is 25.0 times 10 to the power minus 3. So you may get the answer is about 1.08 mole per dm cube. Have you got something similar? Okay, questions? Any questions so far? All right, got it. Now, if not, if there are no more questions, we would come to the some other different cases, right? Which will help you locate the equivalence point. Now, in the previous lesson, we focused on calculations, on determining the equivalence point, right? Exactly, we try to have a handling of maps. How about question 23? Question 23. Question 24, 23. 23 first.做咗23先，23。This one. Now, this is also one of the authentic questions, right? A student was asked to investigate how the pH changes according to the reaction between nitric acid and ammonia. So he slowly added aqueous ammonia to the acid. we recorded the change in pH, and here comes the pH titration curve. Okay, name a suitable apparatus to measure 25.0 cm from nitric acid. So you may see the word 0.00 nitric acid. So just deliver once only, right? You need not add ammonia drop by drop. So what is that apparatus? 25.00 cm cube pipette. So you need to spell the word in exam, pipette. B, use the graph to obtain the pH of the nitric acid before adding to the aqueous ammonia, and hence calculate the concentration of nitric acid. So where is it? pH of nitric acid before adding aqueous ammonia. Before adding means, which means no alkaline is added, right? It's exactly at 0. So this is the place. While the pH of it tells you the pH of nitric acid. Now no alkaline is added, right? Now you measure it as about 1.00, right? 1.00. So you calculate the hydrogen ion concentration, which is equal to 10 to the power minus pH. 1.0 equals to 0.100 mole per dm cube. And that is the original molarity of hydrogen ions. C. A student could also have investigated the pH change using universal indicator solution. Give one advantage of using pH meter to investigate changes in pH. Now, first of all, universal indicator first change. First change method I can tell because the color of it changes too greatly. Two different colors, too many different colors. So I will not prefer you to use universal indicator, but the question is advantage of using pH meter to investigate changes in pH. So can you think of some points? If you use pH meter, which is better, right? Any good points?
準確啊 ，accurate。
More accurate, more precise measurement. Okay. Point number 1. Why? Why? In terms of what? Why is it say that accurate? Now, because for the color changes color is based on a very subjective human judgment, right? Very subjective. So it will give you some human error. Now, just the changes in color is rather subjective. While you monitor the pH, it's more precise because the monitoring of the pH is rather instant. Okay. So you may see that you are having a continuous monitoring of the change of the pH. Okay, so we will call that because of this point. You may think of, somebody will argue that you may get the pH titration curve that can be produced automatically. Okay, so there are so many points. You just give me one of that is enough. So we will call this type of a continuous measurement. D1. Define the equivalence point. What does mean by equivalence point? The point where what at which what sufficient alkali has been added to just neutralize all acid. Just completely react, right, with all acid. So we call it equivalence point dominantly. So according to the equation, 1 mole of the 1 mole of ammonia is used to react with 1 mole of acid, right? Because this time the acid is monobasic, right? Nitric acid. Identify the volume of aqueous ammonia added in the equivalence point. Where is the equivalence point? Where? This is exactly where the vertical part of the pH titration curve occurs, right? Check the vertical parts. Check the vertical parts, and you draw a line to locate it. So where is it? It's 12.5, right? 12.5 cm cube. It's 12.5 cm cube. Is that clear? Questions? Now you may see this type of pH titration curve that you may bring to question 25, right? Now it is so many different combinations of acid and alkali in terms of sequence, which is added to which, and also the strength of acid and alkali, which will make you different combinations of this graph. Now let's have a recap of which is which. From the curve EFGH, choose the curve which is produced by the addition of forms. Now you may have a matching. A1 譚君柔 sodium hydroxide solution is added to ethanoic acid, 25 ml of ethanoic acid. Which graph would best represent this, E, F, G, or H?譚君柔
Yes. G.
It's G. Yep, G. Now, first of all, this one should be the final one, right? It will make it excess, right? When it's in excess, it's alkaline, very highly alkaline. So you find either E or G. But G should be the better choice because the combination of the acid alkaline reaction is a weak acid, strong alkali type. The equivalence point will be having a slightly alkaline solution. Okay, so it's somewhere here, right? So it is because of the hydrolysis of ethanoic ion. And a slight excess of extra hydroxide ion will make the solution alkali G. 2A, aqueous ammonia to 25 ml of a hydrobromic acid. Hydrobromic. What's hydrobromic?咩acid嚟㗎? Hydrobromic. What is that? 黃成軒 do you know? hydrophobic. Yep, it's HBr. Good. HBr. So what is the nature of this acid? Strong acid or weak acid? Now somebody say weak. So what will you choose? Now when you compare it with HCl, HBr is a weaker acid. Is a weaker acid. So go back to the choice. Which one will you think is more possible? And how about ammonia? Ammonia is weak alkaline. Which one is a possible choice? Each one is a more possible choice. Somebody say F, right? But if you want to, you are going to go back to check the HBr, that acid, how weak it is, right? So the answer should be somewhere here, right? A little bit different, but if you want to take a look at the shape, F is more appropriate to be chosen. Okay, can you get my point? So remember, HBr when you compare with HCl, this one is a weaker, a slightly weaker acid. But when you compare with other organic acid, just like ethane acid, it's still strong. It's still strong. Okay. So F is a more possible answer. How about number 3? Hydrochloric acid to 25 cm cube of KOH. That is H this time. H. Why? Because acid is added finally, right? It makes the solution acidic. So this H is a more possible. Questions? Now how about this? The table below shows information about some acid-base indicators. Which indicators about table will be used for the titration produces curve E, but not for the titration that produces curve F? A final one indicator can be used in E but not in F. 係咪啊？佢意思係咁啦。Which one is the choice? E 用到 F 用唔到嘅嗰隻 indicator 係嘛？E 用到 F 用唔到，so you have going to check of what? Check the pH range, working range. We will call that working range of the indicator. So what is mean by working range of indicator? It changes its color around 1.2 to 3.2. So out of this range, the color will not be changed. If you go back to the lower color, if it's too acidic, higher with the high pH color, we talk about high pH. Then the upper limit. Can you get a point? Okay, so which one? Crescent purple. Why? Its pH working range of the indicator is 7.6 to 9.2, which falls within the vertical part of the pH titration curve. Can you see that? It changes. It will make you change its color. How about F? If I put it in F, a little bit over titration will occur if you insist of using crescent purple. Can you get my point? So you are going to check, which means that you're going to check if the working range of indicator falls within the vertical part of the pH titration curve. Okay. Number 2, give the color change at the endpoint of the titration that produces curve H when nethyl red is used as the indicator. Nethyl red H, you use this. What is the endpoint color change? Small, it's very similar to methorin, right? 3.5 to 5, 3.7 to 5. H. So the color range is yellow, red is here. How about here? What is the color? It's a mixing of the two, right? Except before, we have the indicator is just a weak acid, which will have that two form. Okay, if it is slightly, is very highly acidic, mainly this one dominates the color of the solution. If it's slightly alkaline, or maybe it's not so acidic, this one will dominate. So what will happen in between is just a mixing of two. So the color is from yellow to orange instead of red. Remember, it's from yellow to orange. It's not from red. Is that clear? The final questions. 25 on your book. 25. In an experiment, this one, I would like to show you. This is the third type of the pH titration curve. You see this one is very strange. It's temperature. It's not conductivity. It's temperature. We will call that thermometric titration. While the concept is rather similar, right? So you may have got that too. Explain the change in temperature in the following stages from X to Y, from Y to Z. And secondly, you are going to ask for the molarity, right? This one. So how you get the answer? So, first of all, this is question 35. It is on page 156. Okay, this one. And the neutralization. Can you tell me the nature of neutralization? Neutralization is an exothermic reaction, right? Otherwise, they will not have an experience of temperature or rises. So when HCl is added to NaOH solution, right? So the more the acid is added, the more water is produced and more heat. Okay, when the more and thus more heat is produced. Okay, can you get my point? So how about this point is from X to Y? So what will happen if you talk about y? Y is that, what is that? This is the what point is it? Equivalence point. This is the equivalence point, where NaOH was just neutralized completely. Okay, so by exit, the temperature reaches a maximum value. Okay, so what happened when you talk about from Y to Z? After the completion of neutralization, no more heat was produced. Any addition of excess cold and this HCl, it would lower the temperature of the solution mixture. So that's why we would have such curve, rises and then drop. We have got the maximum. So you may know that Y is the equivalence point. And I would not do the questions on here on the steps to calculate the molarity of NaOH. Very similar steps as before as previous exercise. I just give you numerical answer for this, part 25. And does anyone have got the equal? First of all, equivalence point. You know where? So you need to locate the volume of HCl used, which is equal to 27.50 cm cube. Now you should know this, right? So you do the calculations, and finally, my question is they're asking for the molarity of NaOH solution. Do you know what that is? So nice to have 1:1 mole ratio, which is 0.660 mole per dm cube. So you better go home and stay at home, and while you have a break, while you have free time, spend some time on doing this, and you can get that answer. Questions? Now today, what is the core concept of today's lesson? We focus on what? pH titration curve. You determine the equivalence point. We have got this. We use of indicator. And you can indicate from endpoint. You got the equivalence point. You may think of one more point, which is the conductometric titration. Lastly, this is thermometric titration. So we have got that 4 different methods. Okay. So both heading towards the same thing, but it's to help you locate the equivalence points. Okay. Any questions? Better? Now I see the number rises. today. Questions? Now, so remember that 4 different ways for you to get to know the answer, right? 4個方法啊，你睇清楚係呢4個方法。咁考試咧有機會喺呢4個方法入邊抽問一個。咁我哋 practice 多啲先，好冇？跟住最尾下個禮拜打大佬就會做呢啲唔同類型嘅題目啦，同埋最後一個係咩咧 ？Back titration，back titration 係最緊。Okay, stay tuned. And you'll see you guys in the next lesson next week. Bye bye.